Welcome everybody to this webinar, Introduction to GeoGebra. My name is Tim Brzezinski. I'm the Professional Development Director at GeoGebra. Before that, I was a full-time independent math ed consultant for about two and a half years. My specialty really, or I guess it's more of a passion. My passion is to create environments that foster active, student-centered, discovery-based learning. That's my goal. And so I used any and every math app that existed to help make that a reality. So even though, yes, GeoGebra is an amazing app, it's my favorite, it's not the only app that's out there. I've used a variety of apps, and I believe all educators should do the same. I want to make that very clear. But each tool does what it does well. But here we're going to explore the power of GeoGebra, and you'll be amazed at just how easy it is to use, and how adaptable it is to use within the classroom. So before that, I taught high school math for 15 years and also part-time at the local state university here. Students love GeoGebra, and before I share my screen, yeah, I'm gonna think, I know there's some people that can't hear, but I know a lot of you can, but let me just type something to Denise here. Check your computers. I don't want her to feel like, there. Okay, so let me share my screen and we'll get ready to rock and roll here. So you go to GeoGebra, it looks like this. It's geogebra.org. That's the home page. You see right there. And GeoGebra is huge. And if you've ever visited GeoGebra, and if any of you have ever felt overwhelmed, by the vast amount of resources, and then, oh my gosh, which app are you in? And it's like, people get overwhelmed and they get anxious, and that's understandable. I get that totally. So in tonight's session, here's what we're going to do. All right. So here, we're going to explore GeoGebra really, like, we're going to see the big picture tonight. So tonight's webinar is going to go mile wide, inch deep. All right. And starting the second webinar we'll do in 3 weeks from now, we're in all those following webinars, we're going to go maybe like 5 inches wide, 3 miles deep, if that makes sense. Because I want each of you to explore the power of the apps and the resources and the tools that are available here for you to use with your students to foster discovery learning. All right, Denise, you got it. But at the same time, we want to make sure we get everything. So tonight we're going to go very broad and barely, dig anything, 2 inches. But in the next coming weeks, we'll go like a little bit broad, and we'll go very deep, a little bit broad, very deep. That's how I want to plan these webinars out for at least the rest of the year, because there's so much to learn here, and there's so much that we could do in the classroom as well. So let's get ready to rock and roll. First things first, what you want to do is to actually create a GeoGebra account. If you have never done so, I'm going to ask you to create an account. What you do is go up to the upper right corner where it says sign in. Click on sign in there, and honestly, I would recommend you doing it through Google, okay? Because most people have Google account, and that way you don't need a password, which is nice, right? But once you go ahead and sign in, fill in that information. It takes about 2 minutes, not even. You can do that. If you register via email, it takes 3 or 4 minutes for that confirmation to arrive to get started. But I'm assuming a lot of you do have GeoGebra accounts, but yeah. While some of you are doing that, as I'm speaking, I'm just gonna throw this out there for you as well. But if you want to actually go here, I'll leave that on the screen there. tinyurl.com/GGBRES. That'll take you to several ready-to-use resources that you can open up readily in any internet browser and use with your kids in class, because GeoGebra is consisted of really 2 things. You have apps and you have resources. Resources or activities, we could call them, are elements that people in the whole community internationally have made and they use with their students. Many of these teachers have made these resources public for other teachers to also use as well, okay? And so, by the way, that doc takes you right to here. And so, in each one of these pictures is a hyperlink, for example, to resources you could use for, whatever. Okay, but we're not gonna focus on resources tonight. We're gonna focus on apps. But I wanted to leave you with something to go with tonight there. And also, if you're interested in more, if you have a phone on you, feel free to, if you take a picture with your phone there, that barcode, that thing there, barcode. I post teaching ideas on, Instagram, Twitter, Facebook, if you want it, it's there. Help yourself. It's that second slide there. But let's stop wasting time and get right in the apps. GeoGebra here. So let's actually look at the apps of GeoGebra. Now it says over here, new math apps. We have graphing calculator, 3D, and there's more apps. And if you count them, that's a bunch of apps. And it's overwhelming. Where do we start? I like to refer people right to the corner here. These 9 squares. If you click here, these are the main apps that most people use. If you need a GeoGebra app, best to get it from that menu in the corner there. There's a graphing calculator, geometry, 3D, CAS. There's a scientific one, which is really the graphing calculator without the graph part, Think of this as like the equivalent of a TI 30X2, you know what I mean? Like there's save $14, don't go to Walgreens. And then there's a GeoGebra Classic. All right, what I'm actually going to ask us to do right now is to actually right-click on GeoGebra Classic. Let's right-click on it and open a new tab. All right, and so a new tab pops up to the right there. We have GeoGebra Classic here. Okay, now many people, have any of you seen? I'm sure many of you have probably seen this. Is like this app has been around for many years, the Classic app. Okay. And this is GeoGebra's most powerful app that's out there, the Classic, right? And if you look at this here, yes, you have a graphing calculator. You could type something in, see what I mean, and get something like that. But over here, if you go to the hamburger menu, I call it the menu, right? If you go to perspectives, I'm sorry, yeah, go to view. My bad. Go to the word view down here. Go to menu. Go to view. Okay. You will see several perspectives here that you can click on. I'm gonna click on the 3D graphics as well, just to show you what I mean here. So see how in this GeoGebra Classic app, I have a graphics view here, and I have a 3D graphics view off to the right. I can also show another graphics view. See, I could show a spreadsheet. This thing can get overloaded pretty darn quickly. That for all your AP stats, everything. This is a great, amazing app, the probability calculator right here. Okay. But, and this app is big because, you type in, say, a quadratic, you'll see it both in 2 dimensions and 3 dimensions, right? X squared, you see what I mean? You see that function f in 2D, and you also see it here in 3D, okay? But now if I were to type, say, a surface of 2 variables, x plus sine y, well, now we're talking, whoops, second here, sorry. Now if I were to say xy, well, now I have a surface, and GeoGebra knows, hey, we're in 3D now, okay? But many teachers were using this in years past, and they're thinking, I don't need this part. I only want this part. And some teachers only wanted 3D, and I don't need the graphics part here. And so GeoGebra listened to all those teachers. It was coming from all over. And they said, all right, here's what we'll do. GeoGebra took these apps, and these perspectives, I should say, and they decomposed them. All right, so for example, there is an app only for 3D. Like this little part of the Classic app, there is one big app that, in my opinion, is much easier to use, and it actually works literally, in just one single app. And then there's the graphing calculator and geometry apps, which are really algebra plus graphics. And so I'm going to exit out of that one. To go back to main screen here, I'm actually going to tap into the graphing calculator. So let's go back to our first tab we were in, okay? And let's go to the graphing calculator here, okay? If you go there, many of you will get like a notice that says, hey, in order to be more compatible with exams, yes, I'll type it in, Cindy. Hang on a second. I think that's it. If it isn't, let me know. But with this graphing calculator, GeoGebra recently changed this, and so that a lot of the geometric construction features have been removed. This calculator is actually able to be used on high stakes exams, right? High stakes summative assessments, pretty much. And if you look at it, there's very few tools here. But I just want to show you some of the functionality. Like, many of us are used to the TI 80, 90, whatever, you know what I mean? The Cassia, whatever it is. These calculators you have to buy, $100-something for. But if you have the device, a device here, a school is issued to you, GeoGebra comes on it, you can just get it, free. And I got to make this disclaimer. People say GeoGebra is free, and just like, technically nothing in life is free. I want to just, address the elephant in the room right now. A district has to pay for the device that GeoGebra is on. right? So there's always a cost somewhere. You know, I have personally worked in schools in parts of the US where some parts of the school are off the grid. And if a handheld is the best I can get, then I'll take what I can get, you know? But right here, again, you know, GeoGebra works very well. If I just type in a function, say x squared minus, notice I don't need y equals, x squared minus 5x plus 1, right? Just type in the expression, GeoGebra is thinking, oh, you're graphing a function, right? So if you hit enter, notice here, right, you could just touch the curve. Oh, any special point you can anything you need to get on a high stakes exam, you could easily get here. How long does this take to get on your handheld? You know what I'm talking about. It's like it takes a few seconds. Here it's like you just touch it and you got it, you know? Pretty cool. Same thing with finding intersections. Let's type in the line x minus 1, right? Ah, where do they cross? There, there, there. Anything that the students often need, they can just get right away in this app. GeoGebra Graphing Calculator also makes regressions easier. We study linear regression, polynomial regression, exponential, right? Right here, for example, let me just actually, oh, by the way, we can make a table of values. If you want, just check, the way to get there is click on the snowman. I call this the little snowman right there. There's the line, you got the snowman there, table of values, and tell it what you want. I'll start at -10, go to 10, and step by ones, why not? And lo and behold, there it is on the side. And if you check it out, GeoGebra actually plots those ordered pairs right there. It's pretty cool. All right. Now, another thing that's pretty cool, and you can do this also with regressions. So how many of you, when you've done regressions on a handheld, you often, you know, you have to type in your L1 here, your X's in one column, you type your Y's in the other, right? And then you do your regression, what you do on the calculator. Well, if you're like me, then have you ever like put one less X and one more Y and you're thinking, oh, great, I got to fix it all over again, you know? But here, the way you do regression is you literally just type in the points. Let's say 3, 4, 10, 2, I don't know, 1, 5. Just make it, I'll make it up as I go along, 2, 9, right? And let's turn these off. Again, turn functions on and off. We just turn on the bubbles and off the bubbles there, right? And I could actually get rid of this table too. There we go. So now we're back here, and and you can actually drag this around too. You can do whatever you want, right? Now, let's first do a line of best fit. Okay. So the way to do that here is very simple. You click on, now this is the algebra view you see right here, and over here the tools we have the tools. Oh, I think what I need is right there, huh? Best fit line. Let's touch it and see what happens. Well, it says select several points, or what does that mean? Well, here's what I call it, lassoing. You click on the tool, and what you really need to do with your mouse or your finger on a tablet is to literally drag. Just basically highlight everything using your mouse. See what I'm saying? And then let go. There it is. Okay. Now, notice here, again, I'll do that again. You just click on the best fit line tool, touch your mouse. I like to go to the upper left of the points and start you have to press your mouse down and hold it. Just hold the mouse down and let go. It makes the line appear. And to get the equation of that line, go back to your algebra view right here, and you'll see it. Now, some of you, I think, who are there, you're like, Tim, how did you get 2 decimal digit accuracy? My decimals are like, oh, I got 13 places, right? Some of you seeing that? GeoGebra, like handheld calculators, will show as many values as it can. So if you want to set the rounding, go to the settings up here. All right. Click on the settings gear. Click on settings one more time. And you want to click on settings the third time. It's that third gear, like right here. Click on that gear right there. Okay. And then here's where you could do it. Rounding. There you go. Oh, the teachers in the US talk about or even around the world, English is second language, right? You know what? Take your pick. GeoGebra has a team of volunteers all over the world. I think there's like 72 plus different languages here. And the tools will literally, you know, the names of the tools will appear within that language. It is unbelievable. Okay, it's amazing. you know, and US teachers talk about, you know, like 504s, IEPs, you know, this is an IEP meter, like, you know, beyond the beyond. It's amazing. And so obviously I like to, and also chemistry teachers, sig figs, whatever, but I like to round the 3 decimal places, you know, whatever. But there you go. And so now, oh, now it's stuck in this froze. There we go. So now I can actually change this and see how it changes over with there. Now, there's a workflow issue that GeoGebra is going to fix. It's not an issue, but many of you, some teachers don't like, this is in standard form. It should be in Y equals. And like, yeah, in the next sprint, that's, I think they're working on that to have this output Y equals instead of a standard form. Okay, just FYI, that is coming. But you can actually get that right now if you want to, because you know why? Instead of doing that, what you could also do is put these points in a list. And you're thinking, what do you mean? Well, let's go to the tools right here. And under points, there's list. Okay, the list is right here. Anytime you want to do any kind of analysis, whether it's one variable statistics, basic mean, median, mode stuff, right? Or whether it's 2 variable stats like we're doing here, the regression, you have to put the elements in a list. The only exception is best fit line. That's like a special case. But you click on list, highlight everybody again and let go. I just put A, B, C, D in a list. Doing that is the equivalent of literally the L1, L2 thing that we're used to on handhelds, you know? And so we go here now, and you see I have a list of points. That's how GeoGebra thinks. And so one of my favorite commands in this calculator here is called fit poly. Basically, it's a way to, it's a polynomial regression tool. I want to fit a polynomial I want to match L1 as best I can, but let's make it degree, say 1. Isn't that really a line of best fit? Well, there it is in slope. There it is in slope intercept form right there. So technically, you can get Y equals right now. You just have to use the fit poly command to do that. But this will change to Y equals very soon. But I could also make it degree 2. Wouldn't that be a quadratic? See what I mean? And you could see how well that picture fits the data. That makes sense, right? You could take a picture of some kind of a bridge or an archway. You could drag it right in here, and you could build a regression for that, and ask students to analyze with that. Okay. You can make degree 3. And by the way, see, this is a calculator that has been basically stripped of its geometric construction features in order to be accessible for high stakes exams. This functionality is needed on high stakes tests, is it not? You know, of course it is, right? But even still, but the thing is, if I tried to find the midpoint of segment AC, you can do it in all the other apps. Like, what's the midpoint of the segment connecting A to C? But in this app, GeoGebra says, don't know what you're talking about, because that functionality is shut off. Technically, the midpoint tool is a geometric construction, is it not? So that's why GeoGebra has actually removed it. Okay, this calculator is safe to use on high stakes exams. You could use it, your kids could use it on their phones, have it locked down. I'm going to do a demo of that later if we have time. If not, then definitely next session. But which is, I think, way more secure than having to check 800 handhelds. Oh, you know, wipe the memory, wipe the memory, wipe the memory. You know, and if students cheat, you'll automatically know. I can show you that later. But right here, and by the way, styling an object here is pretty cool too. If you touch on the graph, you just go to say AA. This is called the style bar. You could change the color. You could change the thickness. See, you could change, make it dash, solid, whatever. You can change you could show the value. Now the value, I think it shows down there. You got zoom is in the way, but see how the equation is right at the bottom of my screen right there. Every object has a name and a value. See how this point is named D, but its value is its coordinates. All right. If you show the value of function, it'll show the equation, right? If for the geometry app, if you show the value of a polygon, it shows its area. In 3D, you show the value, it shows volume. So it's very intuitive with kind of like what we're doing, if that makes sense. So this is the graphing calculator here. And again, in terms of using this to, you can still use this, within class, of course, to build, to discover, to analyze. But again, this calculator is restricted in its geometric construction features because they've been removed. I could put point on the object, see point on object, I could put a point there, hit the select arrow, I can drag it around and see. You see what I mean? But anything that I could do on a high stakes exam, I could do within the graphing calculator. Now this change is very new. It came February 6th. So it's like a month old as of, not even, right? And so basically many educators are actually frustrated that GeoGebra did that because, you know, I'm used to the graphing calculator. Now I got to, but if there's any of you here in the room in this Zoom chat because I've answered a lot of emails about that, but I can't. I was given permission to share this really quickly. If you go to this site right here, all right, this is very unofficial. Just kind of keep it here, but you know, geogebra.org/suite. This is an app that GeoGebra is currently working on. Currently it looks like the old graphing calculator. Some of you in this room, I'm sure, have used the old graphing calculator. And where's the tools? I miss them. Well, in the meantime, you could use this app. This app is going to grow over time. It's going to change in appearance. But right now, it's just a temporary placeholder for the old graphing calculator. But if I click on this and go here, right, you'll see that it says graphing calculator, but it really isn't. But you see how like there's a lot more functionality here, like perpendicular bisector. That stuff is not allowed on high stakes exams, which is why the real graphing calculator has it off. Okay, but this suite app is actually going to change over time. But this is just a temporary placeholder. But also is a way that teachers that still want to use this web-based version can still do so. Okay, right there. But let's take away from that. Now I want to actually go to a more high-powered app here. If you go back to the first one, all right, go to the apps. I want to take a few minutes to show you the geometry app. Okay, the geometry app I believe is the best app for elementary school students and also middle. Okay, middle school as well. It's very user friendly. It's very powerful. Okay. And so, like I said, remember tonight's session, we're going mile wide, inch deep. We just took a few minutes in the graphing calculator. Now we're going to take a few minutes in the geometry. After this, we'll spend a little bit of time in 3D. We'll spend a little bit of time looking at other things. And at that point, we'll take some Q&A and we'll be done by the top of the hour. All right. But let's actually go to the geometry app now, right here. So go back to that first tab you had open. Let's go to geometry and let's see what we can do here. By the way, just because it says geometry does not mean it can only be used in geometry class. And I know you know that, you know, but I just want to reiterate that. Okay. This app is an amazing app. It really, really is. Because look at it. I mean, when you study geometry and elements thereof, aren't these the most natural tools that appear first? You want to make circles, right? Go ahead and play with them for a little bit. You could plot points here and there, right? Take a minute and just mess around. You can make lines. You know, you can draw polygons. If any of you have used Geometer's Sketchpad in the past, you know the way to make a polygon. It's highlighted as you start plotting points, and you know what I mean. So, and the way you close it is just to go back to the first vertex you started with, like that. You see, again, students love playing with this. And when I taught, especially at the beginning of the year, I had many colleagues that were like, "No, we got to get through 2.2 and 2.4." No. Listen, the best advice I ever got before I started teaching back in 2001 was written by a man named, I think, Harry Wong, First Days of School. I love that book. And that was written in the days before, you know, like all this tech that exists today. There was tech back then too, but not as advanced and crazy as it is today in everybody's face, right? But he basically said this is, you know what, learning has absolutely nothing to do with what you as a teacher cover, nothing. You know, teachers be like, I covered 6.3, I covered 6.4. Who cares what you cover? Because the thing is, teaching and learning, that's not about you. It's about the kids. And we all know that. But we tend to have this thing about, we want to make sure periods 1, 3, and 5 prep are in the same place, right at the end of the, you know, it's because we're human. We like to control things. That's just part of who we are. And that's not bad. But if it affects students' engagement within the math curriculum, I think that's something that I think is an with that is something that I think each teacher, wherever they are, you know, is something that they could work on, me included. All right. I'm far from perfect. I never taught perfectly. And, you know, it's like, it's more of a growth mindset. I'm going to refresh this here just to show you here. So like even simple discoveries, like let's talk about the triangle angle sum theorem. Well, let's make a triangle. Let's go to polygon. Plot points 1, 2, 3, and we'll close it. There's my triangle, right? Now, here's the thing. See how the polygon tool is highlighted? It's bold. You got to shut that tool off by hitting the arrow down here, hitting this move arrow or that move arrow. That turns the tool off and allows you to move the vertices of the triangle around, right? Otherwise, you're going to make more polygons. You don't want to, all right? And if you ever make a mistake, there's that lovely magic undo button is right up here. Okay, so right here, right, I could say, okay, well, let's hit the word more. See, GeoGebra doesn't like to overwhelm the users first. It's like, see how like it's nice. This is kind of a nice, easy, like whatever. But now it's like, holy moly, there's tons of tools here. Yes. So if I go ahead and touch under measure, they're categorized qualitatively. Go to angle and just click inside the polygon. They all appear. Again, touch the angle tool, click in the polygon, and boom, there's your 3 angles. But again, you got to turn the tool off. I have to turn that off. Now I can move this around. And in the geometry, when you do it this way, the angle's default 0 to 180 if you just click on the polygon itself. But notice here, alpha, beta, and gamma. GeoGebra uses Greek letters to denote angles. And even if you're teaching this in 5th or 6th grade, there's no reason why your kids can't learn a little bit of Greek, is there? Some teachers like ask me, oh, can I shut the Greek letters off? And I'm like, well, you could, but why? They can learn some Greek. So if we go over here, see, we're in the tools, we go to the algebra view. See how it's kind of nice because see how like unlike the graphing calculator, these definitions are what I like to call more qualitative than quantitative, right? I have points, I have polygons. These are verbal descriptors of what we just did, if that makes sense. But right here, I have the 3 angles, and so there is still a calculator here. It's that little tiny keyboard right there, right? So just click on it for a second. Click on it. And now this pops up. I want to add alpha, beta, and gamma all together. So let's go to the AB alpha, beta right there. It's like the little thing. Let's click on that. And now we can actually, now alpha is where A is, right? So alpha, and I'll hit the plus. And actually, if you have an iPad or do it on a tablet, you have to go back to 1, 2, 3 and hit plus, you know what I mean? And then we'll go to beta, you know. Just because you experience difficulty typing in, it doesn't mean your students will. I'm telling you, because like it's fun because we're not used to this. We're used to just simply typing in a calculator and boom, I want my answer, you know. But here, it's just that it's just learning how to tie your shoes in a different app. That's all it is. But it's very easy to use. Right here in gamma, right there, and then the enter button is right here, that lower right corner, or just hit enter. See what I mean? No, that's 180, and now the beautiful, I can move this around. And see, all 3 angles are changing, and oh my gosh, the students discover informally that the sum of the measures of the interior angles of a triangle is 180. Okay. Now, in a discovery lesson in middle school geometry or high school, I could have my kids now go build the quadrilateral, build the pentagon, the hexagon, the heptagon. I had them do up to nonagon because they build them quickly, and they discover 180, 360, 540. The kids are they're discovering patterns here. It goes up by 180 every time. I don't give them a formula 180 n minus 2. I simply ask them to discover. They discover in this app about the whole 360 thing. You know, they can do that. The thing is, it's all about the gradual release and responsibility of the students, letting the students do the action, and you're kind of taking the side seat. That's what GeoGebra allowed me to do with fostering discovery learning. And by the way, we could save this construction, but I'm actually going to save another construction we do later, because it'd be more fun. You could share it after, but so that's that. But let me actually refresh this app. We're going to do something else in here. Many of you teach, you know, transformations. This is like one of the best apps for it. If you're sticking in the plane, you know, 3D, you could transform in 3D. But let's suppose I'm going to take I'm actually going to import an image here. So let me go to my Finder here. Excuse me. Daffy Duck. Look at this. See here. I'm going to take Daffy. I have a Google image I saved to my desktop, and boom. You could have your kids find appropriate Google images and put them right in here, and we could transform these things instead of a typical triangle or square or whatever, you know. There's Daffy waving high, right? And so there we go. But you know what? People say, Tim, I want to do this with coordinates because we teach rotating about the origin. I mean, the coordinate plane is where algebra and geometry merge together, is it not? So let's actually, if you right-click, you could show the grid. Again, right-click anywhere in the white, just right-click and show the grid. If that doesn't work for you, you can always go up here to settings and hit show grid here as well. I like to show major grid lines, and you want to throw some axes in there? Be my guest, show the axes. And now we could put A and B on lattice points. Yeah, how cool is that? See what I'm saying? Now we can actually dilate, we can rotate, we can do anything. We're going to do that now in the next 5 minutes. And you could do it as if you could watch, or you're more than welcome to do this along with me. If you want to take time to find the Google image, please feel free, or just find any picture on your desktop and drag it in the geometry app. It'll just be right there. Go ahead. All right. As you do that, I'm going to style this point here to make it like big. Whenever I make stuff for kids, like, you know, when I make resource for kids, I like to make draggable points like really large. And I'll show the value of the point. Remember, the value of the point is its coordinates, so I'll show that here, right? See what I mean? Kind of like that. And I'm going to plot another point right out here. Again, once I plot a point, I got to remember to go back and turn that tool off by hitting move. And I'm going to show the value here. I'm going to, you know, make it big. So my life is made easy. Oh, I'm going to name this O, because most teachers like to rotate around points named O. I don't know why, probably because books do it. But there we go, right? The most popular we want kids to go is right here, the origin. So I'm going to put O at the origin. Okay, now, so let's actually talk about this. Let's actually see. I'm actually going to type in, let's go here for a second and type in n equals 1 DEG. N equals 1 degree. What's n? Well, n is going to be the angle of rotation. So I type n equals 1 degree, hit enter, it makes a slider for you. See what I mean? It's a quick way to make a slider. You could do it. You could do it other ways, but I like to do that. Okay. And so now let's go back to the tools. Again, I'll delete this. All I did here was type in n equal 1 degree, and it made a slider for me. So now what I'm going to do is I'm going to zoom out a little bit. What I want to do next is I want to rotate Daffy Duck n degrees about O. And you think it's very simple to do here. Go to the tools, hit the word more, and let's scroll down a little bit. Scroll down, and the transform menu is right here. All your transformational geometry tools. Remember, these tools were taken out of the graphing calculator because kids on US tests would be cheating, you know. But they're here in the app. This app looks like the graphing calculator, does it not? It's got the tools here. It has a very similar feel and appearance, right? It doesn't have a table in here, but you don't need to be making a table of values right now. But we could rotate around point. Now, I love lasso, and so here's how to use this. If you click on it, the tool pops up to shows you how to use it. But all you need to do here is take your mouse upper left, drag a box around A and B and Daffy. You see how I'm selecting all three objects? Daffy Duck, A and B, let go. That's my way of telling GeoGebra I'm selecting all these items. Now I have to touch the center of rotation, which I'm going to click on O right here. And now I type in the angle. Well, I could make it a stat, and I could say clockwise or clockwise, whatever, counterclockwise, clockwise. But the name of the angle, if you go back to the thing, remember I called it N? Whoops. I made a slider named N there, and watch what happens. Check it out. N is 109. I got that right there. And I could see here, if I zoom out a little bit, actually, let me zoom in a little bit more. I want to see the ones there. But I can actually put them on nice ordered pairs. And aren't the most popular angles that teachers pick, at least first, 90? Let's make 90 here. Oops, or I could just type it in, whatever. 90. And so now, kids are just, my students in my class, they would gather data. Take any picture you want. I don't care, as long as it's school appropriate. And then I want you to rotate 90 degrees about the origin. Tell me the coordinates of the image point. So students discover, they make a table like, oh, 2, 5 is mapped to negative 5, 2. 4, 1 is mapped to negative 1, 4. Okay, what about 180 now? Let's see, Daffy's going around there, right? And so, you see what I mean? They could do literally just that. Oh, this goes to that, this goes to that, and what's the other popular angle, 270? Oh, XY goes to what? Y, negative X, whatever it is. But see, instead of traditionally teaching, direct lecturing the students here, you know, basically open their brains, dump the knowledge in. Now let's do this worksheet. let's spend class time having the kids build these things and discovering these principles and relationships for themselves. GeoGebra empowers me as a teacher to empower my students to do literally just that. That's why I love it so much. You know, it's so much fun. And by the way, you can and let's actually, I'm actually going to delete this stuff. I'm going to actually show you a dilation now, really quickly. So before we dilate, I'm actually going to make segment AB. So I'm going to go to the tools. And segment right here is under lines. Here, you can make segment AB. Okay. Now it's not shown here, but I'm going to hit I got to turn the tool off by hitting it. And I want to show how long it is. Show the value, show the label. Remember, the value of a point or the coordinates, the value of a segment is the length of it. That makes sense, right? So now right now, oh, by the way, I could have moved before. I could have moved all around and Daffy would have moved accordingly. You know, I mean, I believe in doing this on paper. It's valuable. But the thing is, if you want to have a different center, that's a whole different diagram the student has to draw. It takes many minutes to do so. But in GeoGebra, you have one app, you have one file kick and open, and they could actually make conjectures. The Einsteins of the class, where a lot of the class is struggling to say, maybe discover what you want about 0, 0. You could have some kids who have finished already. Can you make me a rule now that tells me what if an object is rotated around the point -5, 3? What would the coordinates of the image be? You see what I'm saying? You could you could differentiate flexibly that way as well, without having to make a brand new paper diagram, if that makes sense. So, but let's actually put this back at 0, 0. We're going to dilate now. But before I do that, I'm going to type in K equals 1. Isn't K the most popular dilation factor? You know, like usually I call it K, right? So K is 1 there. So let's actually see how we dilate. We have everything we need. Go to the tools, you go to transform, and right here, dilate from point is right there. So let's click on it. All right. So the way that it tells you how to use it, but the way that this dilation tool works really quickly is you still have to select everything you want to dilate. I want to dilate Daffy Duck, the point A, the point B, and I'm going to dilate the segment as well. Why don't we, let's save time and dilate points and segments simultaneously, shall we not? Let's do it. I select everything I want to dilate right there. Now I select the dilation center, which I'm going to call O. And now it tells me, hey, buddy, type in a scale factor, right? Which this is everything you need to dilate. So, but I made a slider before called K. So I'm going to type K there and check this out. Oh, wait a minute. Where's the image? Oh, snap. Oh, K is 1, so it's on it, right? But I could move it out here. But watch this. Whoa. Hey, look at that. So I asked students these questions off the bat without even telling them. I said, hey, you know, what makes what scale factor makes the image map onto itself? Well, they immediately discover it's 1, right? What makes it disappear altogether? Well, 0. And what happens when the scale factor is negative? You know, it flips. And some kids can actually go on and discover that, you know what, you know, you can ask students to somehow informally prove that, you know, dilating an object about a point with a scale factor of -1, isn't that the same as rotating that object 180 degrees about the point? So we could talk about equivalent transformations. We could dive deep, and kids could do this rather quickly. They really can. So now I ask students this, oh, by the way, you could actually take this image. If you click on it, see that little teardrop? You could adjust the opacity. So it doesn't you could see how it fades nicely. It's beautiful. I love that. You know, it's so cool. Got to go there. Look at that. And even if you make the scale factor 5, Daffy looks just as clear as he did. See, look at him, as he did before. It's pretty crazy. But now I would ask, zoom in, I should make that scale factor smaller, right? You could ask kids, you know, say, hey, can you make a conjecture here? Like, see how you have an F and an F prime? Let's just, you know, we can get rid of Daffy later, but what do you think is true about F and F prime? I just ask the kids, don't tell them, I ask them. They move A and B around, right? What do you think is true about F and F prime? And most students, not all, but most students figure out they're parallel. So you say, yeah, okay, so I don't say very good. Yeah, it's like, well, can you convince me they're parallel? And I'll leave that to you. Can anybody convince me that those segments are parallel? You could type it in the chat or just unmute your mic. Are there any tools here we could possibly use to convince us that those segments are parallel? Let's give you a hint. Say anything now? Maybe here we can measure. I don't see anything in the chat here. Just looking for the, oh, there's the chat. I'm sorry. Oh, it's hidden over there. Slope. The image, I'm sorry, I didn't see that, Alejandro. The image was, it was just I just took a screenshot. I just basically, it was a dot, whatever. What was it? PNG. I think you could throw JPEGs in there too. Cindy, yes, slope is an awesome tool. That's a much simpler way to go, right? I could have kids measure the slope of this this thing. So let's go here and let's see. It's under more. You got to hit more twice. And there it is. Slope. Just touch it right there. Slope is -1/2. Slope is -1/2. It appears right there and there. Pretty cool, right? But you can literally do that through what's right here. So the students see. Talk about a rich connection between algebra and geometry here. All I do is ask kids questions. They discover. GeoGebra is the conduit through which they do that discovery. It's pretty amazing. Another way we could also do it is just measuring a pair of corresponding angles. OAB, OA prime, B prime, right? And there you go. See right here? It's I can move that, but see all right there. And then students have to still justify if a pair of corresponding angles is congruent, then that means we have parallel segments there, right? So now students can actually save this. If I'm logged in as me, I can also discover one more thing. If I take F prime, let me go to the calculator here. If I take F prime and divide it by F, should that also be the same as the scale factor? Oh, no way. See that bottom right there? So kids can also naturally come to discover that the connection there. You know, we talk about similarity, proportionality. It's all there. Right? Now, I could save this construction. If you ever want to have kids save it and submit it to you, you could go here, go to save. So in GeoGebra, you go to File, Save. I'm going to call it Daffy. And now there's 3 shared with link. Right? Save. At the bottom, it says saving, save successfully. Right? Now, so now the thing is, now let's suppose I leave this and I want to go back to work on it tomorrow. I want to do something else. My teacher says, where do I find that file? This is where teachers have gotten lost before. So I'm going to show you. Under Profile, see on the GeoGebra's homepage here, you go back. If you go to Profile, you will see, oh, right here. This is like the latest one here is this thing called Daffy. But teachers I've got so many emails from teachers like complaining, like I click on it, Tim, and I can't do anything with it. It's just like, where's the tools? Where's the everything? Think of this as like a view only thing that you can never change. You ever get a Google Doc that you wish you could touch, but oh wait, I can't type in it? Well, here's the thing. If you ever want to make a copy, really you got to hit file, make a copy to make something, right? But the way to do that, if you go back there, is to actually click on the 3 dots and hit open an app. Again, any construction that you save, oh, I got to go, the bell's going to ring, and then you come back in class tomorrow. If you want to open that exact construction up and keep working from where you were, you click on the snowman, 3 dots, excuse me, go to open an app, and look at that. It'll open it up, literally. And that's now I can continue working on my Daffy Duck construction. It'll prompt me to sign in again, just for sake of keeping there. I can sign in through Google. And yeah. So then, and now if let's say I just change it even more. If I go hit file, save, if I keep it the same name, it'll overwrite the file automatically. That's important to know. If you never change the name, all things you did to overwrite will be saved. But if I want a brand new version, I'm going to call it Daffy 2, hit save. I'll have 2 files, Daffy, one called Daffy 2, if that makes sense. Okay. Yeah. So right here, that's a quick little taste of the geometry app. We'll play a lot more in this app in another webinar in a month or two. Okay. So where's the chat? I want to make sure it's hanging in here. So much on there. All right. So now let's actually go back to the main page there. See how I have Daffy and Daffy and Daffy 2 are here to work on. I could save versions of things. It's pretty fun. All right. So now if we go back to here, I can't wait to show you my favorite app. That is the 3D calculator right here. GeoGebra 3D calculator is unbelievable. I'm going to show you how powerful it is first, both on the web version on my computer and on a phone or a tablet here. I have my iPad hooked up, and I'm going to go about 10 minutes, and then we'll take 5 minutes of Q&A. And then if any of you want to stay on after, you're more than welcome to. I could stay on, but I want to respect the hour with the content. Excuse me. So you'll notice here, how did I get the Denise, to get the graph again, what you do is go back to go back to your profile here from GeoGebra. Profile. Your profile is where is your stuff, right? And if you click on the snowman here, you can go to open an app, and that's how you can open an app. In fact, you could if you hit the share icon right here, you could drop it in Google Classroom. Google Classroom is another thing. You could actually assign in Google Classroom and have kids work save in Google. That's a subject for a different session. But if I copy that link, I could drop it in Schoology, I could drop it in OneNote, I could drop it in whatever. And then every kid, when they open it up, will have literally this in front of them. If you preload a construction and you want the student to work in that within the app, that's the way you can do that. Okay. Yes, cool. You're welcome. So let's look at the 3D app for a little bit. Now, some middle, and I say elementary school kids can work in this. And here's my, those of you that know me on Twitter know I'm kind of outspoken about this, but I really have a big problem with the way with mathematics education from really late elementary school to like calculus, because where's the 3D? We talk about, oh, we do surface area and volume, but no. The way it's often taught, it's just basically, two specific examples of, oh, we can do more algebraic manipulations, yes, I use unifix cubes. I make these composite solids. We count surface area and volume, but really spatial reasoning is there, but that's all we ever do with it. We teach kids how to plot points in a coordinate plane. That's 2-dimensional, but the life that we all live in is 3-dimensional. So why can't we plot the point 0, 0, 0, 1, 0, 0, 1, 0, 1, go up 1? I just don't understand why. But I'm going to show you something here. If you don't like these axes, let's hide them. Let's just click on the settings and uncheck show axes. Let's just work on the plane. Why not, right? But just to get a little taste, remember, we're only going mile wide, inch deep. We can't go too deep now because time is up pretty soon. But look here, we can actually just, if you touch the cube, right? Just click on the plane, and boom, oh my gosh, there's a cube, right? Now I'm going to turn that tool off. That's important. I should turn that tool off by hitting move, but I can move it around. But isn't this an interesting question we could ask students? It's simple, but it's kind of like deep though. Why is it that GeoGebra spits out a cube when I only plot 2 points? Talk about some deeper connections here. Well, wait, a cube has congruent like 6 squares and all, but you get the kids discussing that. Wow, all you need are 2 points to make a full cube. You know what I mean? That gets the kids' brain process thinking there. What about the net? Check this out. You want to have kids explore nets? Click on the net tool and just touch the cube. Whoa, what just happened? I'll undo. I might have done that too fast. I'm sorry. Well, let me redo the cube. Oh, yeah. So again, let me delete the net there. Touch the net tool and touch the cube anywhere. Now turn the net to hit the move tool, touch move, and watch what happens. You can actually fold it back up and look at it from any angle right here. Isn't that unbelievable? Unbelievable. And we're just getting started, right? Let's talk about a lot of the things. So I often like to hide the cube and I just like to hide the cube and like leave the net. And so instead of telling students, oh, 6s squared, it's like, well, hang on. You know, can you find the surface? Ask kids to find the surface area of a cube. If they know how to find the area of a square, they can find the surface area of a cube. It's just some kids need this visualization. There's some that don't, but there's a lot that do. And you could have them go here and make it. They can make it. You don't even need to give them step-by-step directions. If you let the kid, when I used to have my kids there, I was never worried about where other colleagues were. In the very beginning of the year, I was like maybe 3 weeks behind because I spent days having my kids play in GeoGebra. They became I learned from my kids, my students, GeoGebra better because of them. And so basically so my kids discovered everything a lot in GeoGebra and paper folding and stuff like that. But by November, December, I was like, I had to slow down, you know, because some other teacher, you know what I'm saying? It's like you could start anytime, anywhere in GeoGebra. Give your kids a full period to play with it. See what they can discover with the stipulation. You guys, I want you to discover 3 new things that you didn't know before that you can know. You gather a whole collection, have class show. You now have a class that's more, you have a class that's now powered. We want to do this tomorrow, you know? Another thing you could also do, let me delete the net, is you could take something like this. If you touch A, B, and C here, actually, hang on a second. Let me just delete this all together. Let me delete A and B. Let's actually go to, let's actually simply make a plane through 3 points. You touch, you move up. You click on the plane and you can move that below. You click on the plane and you could, oh, wow. Oh, wait, yeah, any 3 non-collinear points always determine a unique plane. Right. But guys, how do 2 planes cross? I forgot. I mean, yes, I use the whole ceiling and wall illustration just like many of you do. But right here, well, if the kids really can't see it, we have a command called intersect 2 surfaces where they could just simply, oh, boom, boom, touch, touch, and there it is. Oh, epiphany, it's a line, of course, you know, and students can play with that all they want. That makes sense there. Okay. But that's, again, we're starting to explore the power of the 3D app here. That on a web-based version, okay, one of the sessions in April, we're going to spend solely in the 3D calculator. There is so much you could do. You can rotate stuff about planes. You could reflect about planes. You can do, it's unbelievable. Unbelievable. Many ways to build a cylinder. And within building that cylinder, you could reach kids in elementary school, but you could also reach students who are taking like who are studying parametric equations in pre-calculus, say. All right, we study parametric equations only in 2D. Why? The world is 3D. Let's build in 3D. They can have a spot, like you take a circle, like X is cosine T, Y is sine T. Just let Z of T be T, and then you can make a spiral going up. You know what I mean? It's so simple. And we'll do that in another session. But I want to end with this before we take some questions here. I want to actually show you here something on the iPad here that I'll actually, let me get this up and running. Now, GeoGebra is available for download on Androids and iPads, totally. But let's see here. So you can see my iPad screen. Let's full screen. Well, let me minimize that. Here we go. We'll full screen this to make it nice. So let's actually go to 3D Calculator now. Now, see, this is the app that I have my iPad up and running here, but this app is literally just, it's the same as it is in the web version. It's just the app. But look at this. Let's suppose I type a function, say f of x equals x. I'll just type in x, comma, 0 less than equal to x less than equal to 4. Isn't that really the line y equals x from 0 to 4? Again, it doesn't take a rocket scientist to type this in, right? I hit enter. There it is. That orange color is ugly. Well, I'll touch it and I'll just change the color right now. Simple. All right, now I'm going to do the same thing. I'm going to go ahead and type in n equals, and you can do this online with me too, n equals 1 degree. Again, I'm too lazy to find the degree symbol. I just like to make sliders that way, right? And there is a command. By the way, if you ever use an iPad, with this on iPad, if you want your commands, they're all found right here where the 3 dots is, right there. But in GeoGebra on web version, you can just type it in and it'll populate the cell. But if you click like right over here, I'm going to look for the command I just typed in. And if I start to rotate, I typed it in. It's recently used. I'm going to rotate F, right? I'm going to want to rotate F n degrees. See, that parametric garbage down there, again, not garbage, that parametric stuff, you know, that intimidates middle school and elementary school teachers, but you know what? They don't need that. we're here to study surfaces of revolution and cross section now. Okay, so ignore that for now. Rotate Fn about the x, little x, capital A, xis. Right? And look at that. And actually, I changed it so it was a qualitative descriptor right there. See here? Rotate about the x-axis there. Now, my favorite command of all time here is the surface command. You could type in surface. I want to make a surface of revolution. Now, by taking that graph of F, I want to rotate it n degrees about the x-axis. Well, nothing. Oh. 4 lines of code. And look at what your students can do. Now, students often struggle so much. I don't like that ugly orange. Let me just make it better. Students struggle so much with looking at cross-section and seeing surfaces of revolution. But here, I think this helps bring it way more to life. It's like, for them, it's like, oh my gosh, this is just, what is this? You know? And so now you can ask kids to create. You see, mathematics is a science, but it's also an art. Let's start with simple art. Can any of you make this, can any of you make a cylinder? Like, you ask students, what would I have to do to function F to make that a cylinder instead of a cone? And then you let your students think, right? I mean, many of us teachers know the answer to that question is just, well, just make it a constant function like 2. Isn't this like y equals 2, right? Or y equals, say, 3, see, bigger, right? But I mean, I could do anything, but you know what? Hey, trick teachers, why not actually do a sine function? And see, the thing is, looks like a fish, doesn't it? So AP calculus teachers, you know, we wonder why our students struggle with seeing these surfaces of revolution. Well, our students don't work enough in 3D going through the middle and secondary curricula. But there's no reason why you as a teacher can't start doing that, because if the tests are in 2D, that's a joke compared if they're working 2 and 3D all the time. If that makes sense, right? And also there's a button called AR, called augmented reality, which you can literally touch. If you have an iPhone or an Android, and then you tap it there, you can actually see that solid right in your environment for visualization. Let me actually take that. Actually, let me take that away so you can see it better. And oh, you want okay to go inside? And you have an insurance policy. Let's see here. You can go in. There it is. And we're inside. Any student with an iPhone or an Android can do this. To get the app, if they have the device, it's a free app to download. Now, I don't have time to show you this, but right, I could show you that we're definitely going to do this in another session. But right over here, let me see. And by the way, there's nothing to stop you from taking that fish and actually translating it by a vector. You could start creating a Dr. Seuss animation: 1 fish, 2 fish, red fish, blue fish, something. You know, you could actually translate that fish by a vector. Just call it K00, translate by vector. We've learned how to do the transformations within the other apps. Anything is possible to do here. So yeah, so that's just a quick little glimpse of what we can do here with GeoGebra. And so thank you for joining us. I'm gonna have the next webinar coming up like at about I think March 25th is 3 weeks from now. We're going to spend some time working in, I think, either resources or in apps. I haven't figured it out yet, but I'll put something on Twitter probably about next week. But if you want to save the date, 3/25, it's a Wednesday. We'll be back here at 9 o'clock Eastern. We're going to explore GeoGebra in we're going to actually limit the scope of what we cover, but we're going to go a lot deeper into it. Okay. So I'm going to stop. Thank you for coming. I'm going to stop the recording now. And if you have questions, feel free to unmute your mic and ask away. I'm happy to stay.